In this first example, just move that over, you can see that we've got an x squared in the denominator. So like I said in the previous video, when you've got a variable in the denominator, you multiply by the variable. So we're going to multiply by x squared. Now, you'll notice here that rather than me calling it x to the fourth, because I'm squaring that, I actually wrote it as this term squared plus 4 plus 5 times x squared. Now, the reason being, it's a little bit easier to identify that we've got a quadratic where the variable is actually x squared. So here it's being squared, so let u be x squared, and then it becomes really obvious that it's a quadratic. So it's u squared minus 5u plus 4 is equal to 0. Factorises to u minus 4, u minus 1, which gives us u can be 1 or 4. That is, x squared can be 1, which means x is plus or minus 1, or x squared can be 4, so x is plus or minus 2. Now, with this second example, hopefully, you can see that the x squared minus x appears in two terms. In this term, the x squared minus x is being squared. Here, it's just x squared minus x, and then we've got minus 2 equals 0. If we were to let u be this common bracket, x squared minus x, then you can see that we've got u squared plus u minus 2 is 0. So we've got a quadratic. Now, we can solve that quadratic. There's just one thing that I also want to point out, and it's important not to overlook. The instruction has been to solve this giving exact values. What comes to mind with exact values? Hopefully, a surd. So it's indicating that you will possibly have a surd in your solution, and a surd in a solution involving a quadratic leads me to think about the quadratic formula, the minus b plus or minus square root b squared minus 4ac all over 2a. However, back to this situation, it's not looking like I need to go to the quadratic formula. I can think of two numbers that multiply to give minus 2 that add to give 1, in that they will be plus 2 and minus 1. So I'm getting that u is equal to minus 2 and plus 1. However, when we solve now or replace u with x squared minus x and put it equal to minus 2, then I get x squared minus x plus 2 is equal to 0. And I'm thinking about two numbers that multiply to give plus 2 and add to give minus 1. I think it's going to be here that this exact value for x will actually become obvious. So I cannot think of two numbers that multiply to give a positive 2, which will also add to give a negative 1. So I'm going to go to my quadratic formula for solving this, which is x is equal to minus b plus or minus the square root b squared minus 4ac all over 2a. So I've got minus b, which is 1, plus or minus the square root of 1 minus 4 times 1 times 2. I think I'm going to have an issue here because I'm trying to take the square root of a negative. 1 subtract 8 is -7 on 2, no solution. Let's see then so there was no solution when u was -2. What about when u, which is x squared minus x, is 1? So if we get x squared minus x minus 1 is equal to 0. And again, are there two numbers that multiply to give minus 1 that also add to give minus 1? I don't think so. So we go to the formula, minus b, which is 1, plus or minus the square root, 1 minus 4 times a times c, that's better, all over 2a. So it's 1 plus or minus the square root of 1 plus 4, which is 5, all over 2. So here's our exact value. Here's the surd we've been expecting, and we write our answers like that. So it is really important to take note of little things, even little things like this in a question, because it's an appropriate hint. It tells you exact values, tells you you're going to have a surd in your answer. And from that, if you're going to have a surd in your answer when you're solving a quadratic, then you're probably going to need to use the quadratic formula. And while it didn't work with our first solution, it did become obvious in the second option for you. I think you should be right to do exercise 8D now.